Welcome to PowerUp, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on power electronics technologies and products featured on powerelectronicsnews.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges, and opportunities for power electronics in markets such as automotive, industrial, and consumer. Here is your host, Editor-in-Chief of Power Electronics News and Embedded.com, Maurizio Di Paolo Emilio.
Hello everyone, and welcome to another episode of PowerUp, where we explore the technologies shaping the future of power electronics. Today's episode is brought to you by our sponsor, Texas Instruments, a leader in advancing semiconductor innovation across automotive, industrial, and IoT applications. Today's discussion is on one of the most important transformations happening in the automotive industry, the shift from traditional 12-volt electrical systems to modern 48-volt architectures. For decades, 12-volt has been the backbone of vehicle electronics, but with the rise of electrification, ADAS, infotainment, and software-defined cars, the industry is moving towards more powerful and efficient solutions. To help us explore this exciting transition, I'm pleased to introduce our guest, Madison Ecklund, Systems Manager in the Automotive Body Electronics and Lighting Systems team at Texas Instruments, TI. Madison brings deep expertise in automotive power management and system design. She is responsible for zone control modules and power distribution boxes. She holds an electrical engineering degree from Vanderbilt University. She has experience in EMI, EMC compliance, 48-volt low voltage architectures, and automotive Ethernet in vehicle network evolution. Let's talk with Madison. Hi, Madison. Thanks a lot for being here at PowerUp episode. How are you?
I'm good. How are you doing today?
Thank you. I'm fine. Where are you located, Madison?
I'm based in Dallas, Texas.
Good. Nice place. So the topic is the shift from 12 to 48 volt in automotive, as I mentioned at the beginning. So before sharing my questions that I have prepared for you, so tell us more about you. Could you introduce yourself?
Yes, I'm Madison Ecklund. I am a systems manager with Texas Instruments. So I'm specifically part of a centralized automotive systems team that focuses more on end equipments and not necessarily on the actual parts, but looking at the whole system and kind of what we need to do there to help with our customers and with our sales teams. And I specifically within that focus on body electronics and lighting and zone and body domain controller end equipments.
Great, thank you. So let's start with my first question. So let's start introducing the topic. So the automotive industry, as you know, has relied on 12-volt systems for decades, a couple of years, but electrification and advanced features in terms of different technologies are accelerating change. So what are the main limitations of 12-volt systems, and why is the shift to 48 volt becoming essential?
Yeah, so in general, I will kind of want to start with some of the background. So I think a lot of people don't know, but in the 1960s, we actually were using 6-volt batteries. So once we hit 1960s, that's where it was a natural inflection point that we needed to move to the 12-volt battery. And now with 12-volt systems, it seems like we're at another natural inflection point where the current requirements and the power demands just keep going up in these vehicles, especially with more autonomous driving vehicles coming and trying to achieve higher levels of autonomous driving. It's driving up these power requirements. So it seems like now is the right time to make that transition to 48 volt. One, to get more power, and two, also to optimize wiring in the vehicle. That's one of the other big trends happening right now is with BEVs, they are a little bit more expensive maybe than some of their ICE counterparts. So we need to do everything possible to kind of, reduce cost. And one of those ways is reducing the wire harness.
Good. So, OEMs weight, cost, complexity, performance carefully. So how can adopting 48 volt actually reduce system level cost while introducing even more advanced components? So may do some examples as well.
Yes. So in general, the main benefit of going to 48 volt is reduction of the wiring harness. So by voltage going up and current coming down, the actual gauge of the wire harness can be reduced. So that directly relates to copper used in the wire. So first, you're going to get a lot of benefits from cost just in the wire harness itself, but you're also going to get benefits in other places as well. So the actual connector size could be reduced due to the current requirements. The actual PCB traces and thermal requirements, ounces of copper needed on the board could also be reduced. So those are a couple of places that we see that OEMs are kind of really looking to optimize for cost. The other thing to remember, though, is that 48 volt is still an emerging market today. So it's still very early. So we're still waiting for breadth of more devices, more actuators, more people to get into this space. So at first, it may seem more daunting, a little more expensive, but OEMs are really looking at the long-term gains. What does this mean for the future?
So when we are talking about electric vehicles, so a common topic, a common concern is the range, the range anxiety. So that we have to reduce also to guarantee a strong adoption of electric vehicles from consumer point of view. So how do 48 volt systems actually increase the vehicle range and reduce weight as well?
So I think this all comes back to the wire harness, right? So by actually reducing the wire harness, that also directly correlates to weight. So less copper, less weight. So that's one thing. The other thing is that we're trying to optimize with 48 volt systems. So trying to, reduce the power requirements and, save some of that battery ultimately. And everything's just trying to optimize and become more efficient in the end so that we can have more drive range.
So let's talk about safety and reliability. So reliability, talking about system devices is a hot topic. So how does the move to 48 volt improve the overall reliability in terms of overall system reliability?
So in general, I would say safety and reliability have always been a concern, even in 12 volt systems today. So we have a couple different standards like ISO 26262 and VDA 450, which really govern, safety requirements as well as safe power distribution. So there are a lot of things happening in the 12 volt space that will definitely be carried over to 48 volt. It all comes down to the upfront power architecture for actual maybe redundant power distribution, intelligent load management, as well as freedom from interference. So OEMs have to take into account all of these different things. So for example, say you have a braking system in your car. You will likely have two power supplies going to that system so that if one of those supplies fails, it can rely on the backup in that case. So a lot of those same things that we see in 12 volt will still happen in 48. It'll be at a different voltage level in the end.
So, talking about design considerations, so introducing higher voltages. So, may you elaborate in terms of what are the main design considerations to ensure reliable, safe power distribution 48 volt systems?
So with the introduction of 48 volt, we're actually seeing a little bit of changes in the actual power architecture today. So in previous, zone architectures that are starting to happen at 12 volt, we see kind of a top-down power distribution network where we have, you have your supplies, whether that's a low voltage battery and a high voltage DC-DC, going to say a power distribution box. And from that power distribution box, it provides power out to the zone control modules, central compute, whatever those main power modules are, and then the zones provide power from there. One of the key things that we're seeing with 48 volt is it's allowing more consolidation, even more consolidation than we see with the initial zone architectures. So when I say that, I mean we are actually looking at doing a backbone power distribution. So they're looking to get rid of a power distribution box in that case, and then just do power distribution through the zones only. So the zones would be your first level of power distribution and your second level of power distribution. So the key thing there that they're trying to do is they're looking at these new topologies to, again, remove the power distribution box. So ECU consolidation, and reduce more wiring in the vehicle.
So automotive design, so as also you mentioned, is shifting in terms of zonal architectures and software-defined vehicles. Both would require scalable power rails and robust as well. What about the adoption of 48 volt would reshape the vehicle electrical design? So the role in enabling zonal architecture and software-defined car in particular.
Yeah, in general, what I see is that we have kind of three big trends happening within automotive moving forward. One of them is optimizing power in the vehicle. So that's 48 volt directly. The other one is in-vehicle networking. So optimizing that to achieve software-defined vehicle. And the third one is consolidation. ECU consolidation and optimization of wiring. And that's kind of where I feel Zone is playing into both the 48 volt and software-defined vehicle spaces, because it's doing ECU consolidation. It's trying to optimize wiring. And 48 volt really is just taking it to that next step. It's further optimizing the wiring in the vehicle.
So let's analyze some solutions that TI is offering. So transitioning from 12 to 48 volt can feel complex, but solution semiconductor innovation for sure help in this case, in this shift. So what are some of the key technologies in TI's portfolio, such as current sensing, motor drives, and so on, that can support this migration? So how does portfolio range help OEMs and engineers simplify design challenges?
Yes, so I would say from TI point of view, we're definitely very heavily investing in 48 volt. We see this coming and we see this happening at OEMs. What I see is that I really try to put it into three different buckets for how 48 volt is impacting semiconductors. So the first one is really power distribution. So all of these ECUs that were 12 may now migrate to 48 volt. So that directly impacts smart eFuses. It directly impacts ideal diode controllers for protection at the input. As well as it could impact our communication transceivers if they are running in the same wire harness as this new 48 volt power distribution. I also see for load drivers, now you have most likely high current loads will transition first to 48 volt. And that's where you have things like motor drives, power switches, high side switches, maybe even audio amps, things like that, that will transition to 48 volts there as well. And the last bucket is really power conversion. So now that we have 48 volt, we will still have 12 volt, 3.3, 5 volt still in the system. So that's where we will have, wide VN DC-DCs that are going to do that translation. So in general, TI's approach is to do breadth, right? So we are trying to play into all of these spaces. And to note, we were first to market for motor drives and power switches with some of our 48 volt offerings that are out today in production, as well as we have a very heavy presence for DC-DCs, especially for our power solutions we have today. And those are really, I would say, the three key areas that are affecting a lot of this power distribution for 48 volt.
Great. So another topic that I would like to ask, very close to my heart, is wide bandgap semiconductors. So, wide bandgap devices are gaining momentum in automotive. So where do you see these devices, GaN, silicon carbide, playing a role in 48 volt systems? And please tell us more about.
Yes. So for me, I feel like how I'm looking at it is from a zone control module perspective. So what I see is that these zone control modules still they're going to have a 48 volt input, and we're still going to have a lot of legacy 12 volt today. Now, that means that 48 to 12 converter has very high power requirements on it today, anywhere from 500 watts up to 1 kilowatt of power. Now, I really see GaN fitting in here because they're looking to optimize power density and switching, which is really where GaN can really influence, right? So I think that's where we're going to see it start coming into play, especially in zone, is where they want to shrink the board sizes even more and offer more power density and have maybe higher switching to avoid some of those EMC concerns in the systems.
Thank you. So initially, 48-volt systems. So we saw in two mild hybrids, but the role, talking about automotive, of course, is quickly expanding. So where do you see 48-volt solutions having the greatest impact today? Battery electric vehicle, plug-in, and so on. So what new emerging in terms of applications we can expect?
From my point of view, so everyone talks about mild hybrids because that's where 48 volt really started. But it wasn't 48 volt in the context that we're talking about it today. So in mild hybrids, we had both a 12 volt low voltage battery and a 48 volt battery. Pretty much the entire electronics in the vehicle runs off of 12, and the 48 volt is just there for the boost recuperation or recovering of the braking energy. Maybe it drives a couple high current loads like chassis or suspension, but really the entire vehicle runs at 12. Where we're really seeing this 48 volt low voltage rail adoption is in BEVs today. That's really where OEMs are starting. Most of the innovation is happening around BEVs because they're trying to, reduce cost, do a lot of things to optimize those architectures first. So that's where I expect it. I think a good carryover would be plug-in hybrids next, because those are very similar systems still operating off of a DC-DC supplied architecture. Eventually, we may see it come back to mild hybrids and ICE vehicles, but I think really the target is BEVs right now for the next few years.
So as the adoption of 48 volt would increase, so let's talk about standard testing requirements. So how do standards and testing requirements evolve? So what role does TI play in helping customers meet functional safety and EMC requirements at 48 volt?
So standardization is definitely a very key thing happening for 48 volt right now. One big standard that I would like to mention is that we actually didn't have anything to govern the voltage ranges for 48 volt. The existing standard is ISO 21780, which is for mild hybrid vehicles today. Now, that's not necessarily the same application because those are alternator systems compared to BEVs are DC-DC supplied systems. So there's actually a whole standardization effort happening worldwide right now. It's for ISO 25769-2, part 2. And we are, as worldwide people from semi suppliers, tier 1s, OEMs coming together to then work on this new standardization. So from my side, TI is heavily participating in that to help understand, what are these OEMs thinking about moving forward? What are our customers doing? How do we need to help them and what parts do we need to make in the end as well? So this is something that we're very closely watching, as well as functional safety. We see functional safety requirements keep going up in a lot of places, and especially in zone control modules where we're now doing power distribution, possible power distribution to, safety critical ECUs like braking and things like that. So then we need to have, more parts that are according to that ISO 26262 flow.
Thank you, Madison. So in conclusion, just last comments, questions. So for OEMs, the move to 48 volt, it's not just technical, it's also strategic, as also you mentioned, in terms of challenges and priorities. So how do you, looking next, how do you see 48 volt systems evolving from your perspective?
So I think we're going to see still a lot of evolution with these 48 volt systems. Like I mentioned, the market is still pretty early. So we don't have all of the semiconductors that we will need ultimately. We don't have all of the actuators, the motors, things like that we will need. So what I expect is as time goes on and the market matures, we will get more products so that more loads, more things can transition to 48 volt. And what does that mean? So that affects a lot of the 12 volt legacy ECUs. Those will now move to 48 volt. It also affects, some of our DC-DC requirements, where we might have had really high power requirements still on 12 volts will ultimately go down over time. So that's kind of how I see things kind of changing is we will see the power requirements shift in terms of these load drivers and these DC-DC converters. And we'll definitely see more OEMs getting involved in this 48 volt transition. And that's where I see kind of it evolving today.
So if you would like to conclude with key takeaways, so if you would summarize the single most compelling reasons for embracing 48 volt, what would it be?
For me, I think the two key reasons for going to 48 volt The first one is obviously to reduce the wire harness. That's the key one. We want to reduce the wire harness. The second one is to have higher power. This is the natural inflection point, right? So 12 volt has gone exponentially up in its current requirements on the 12 volt battery. So if we transition to 48 volt, we can significantly reduce the current requirements and enable more power in the future.
Thank you so much for joining us at PowerUp, Madison. Thank you. So stay tuned to the next conversation with Power Electronics. Thanks.
Thank you for having me.
This episode of PowerUp was brought to you by Texas Instruments, TI. Thank you very much, TI, for sponsoring us. If you want to learn more about the Texas Instruments solutions we have been talking about today, please check the links on the podcast page at eetimes.com or powerelectronicsnews.com or the TI homepage ti.com. Thank you.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about power electronics. If you are listening to this on the podcast page at eetimes.com or powerelectronicsnews.com, links to articles on topics we have discussed are shown on this page. Power Up is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio and the producer is James Eade.